Let's talk about something you do every day but rarely notice: driving around a bend. It's such a routine part of our journeys that we hardly give it a second thought. But have you ever wondered what's really happening when your car glides through a curve? There's a lot more going on than meets the eye. You follow the curve without thinking, but have you wondered why it feels so smooth and safe? That effortless feeling isn't just a happy accident. It's the result of careful planning and precise calculations. It's not luck. It's the work of civil engineers. These professionals spend countless hours designing roads that keep us comfortable and protected, even at high speeds. Without curves, roads would be a series of sharp, dangerous turns, forcing you to slow down constantly. Imagine having to slam on your brakes at every intersection or twist in the road. Driving would be stressful and risky. Curves are the elegant solution, letting you maintain speed and control. They help your car transition from one direction to another, making the ride not only safer, but also more enjoyable. A well-designed curve works with your car, making the transition feel natural and almost invisible. The tires grip the road just right, and you barely notice the change in direction. That's great engineering, solving complex problems so seamlessly you don't even notice. It's about blending science, math, and creativity to make our roads safer and more efficient. Engineers consider speed, vehicle types, tire friction, and even weather to design curves that keep us safe. They run simulations, test materials, and analyze data to make sure every curve performs under real-world conditions. Next time you're on a winding road or a highway interchange, remember, every curve is a carefully calculated piece of infrastructure. It's the result of teamwork, expertise, and a deep understanding of how people drive. It's not just a bend, it's a testament to the engineers who make our journeys safe and efficient. Their work allows us to travel farther, faster, and with greater confidence. They connect communities, fuel economies, and get us home in one piece. Roads with well-designed curves are the backbone of modern transportation, linking cities, towns, and people. So the next time you take a curve, appreciate the science and skill behind it. Think about the invisible hands that shaped your path, making your drive smoother and safer. It's a critical job that shapes our daily lives. Every curve is a reminder of the dedication and expertise that goes into building the roads we rely on, and that's worth talking about. The next time you're behind the wheel, remember, those curves aren't just part of the road, they're a symbol of progress, safety, and the power of thoughtful design. Engineers often talk about the degree of curve, but what does that mean? It's simply a measure of how sharp or gentle a bend is. A small degree means a long, gentle curve. A high degree means a tight, sharp turn. The arc definition is common. Imagine a 100-foot arc of road. The degree of curve is the angle that arc subtends at the center of the circle. A 1-degree curve is barely noticeable. A 10-degree curve is much tighter. For example, a 1-degree curve has a radius over a mile long, while a 10-degree curve's radius is just a few hundred feet. Why not just use radius? Surveyors find it easier to work with angles and standard lengths in the field. The degree of curve system makes layout and communication simple and practical. It's not about making things complicated, it's about making road building efficient. It's the language of the people who turn plans into pavement. Not all curves are created equal. Engineers use different types for different situations. The art and science of road design is about more than just connecting 2 points. It's about shaping the journey itself. Every curve you encounter on a highway is the result of careful planning, mathematical precision, and a deep understanding of how people drive. The simple curve is the most common, a single constant radius arc connecting 2 straight roads. It's straightforward, easy to design, and ideal for places where the landscape is open and there are few obstacles. You'll find these curves on rural highways and in places where the road needs only a gentle bend to keep traffic flowing smoothly. Compound curves combine 2 or more arcs with different radii, bending in the same direction, perfect for weaving around obstacles. These are often used when a road must snake through hills, forests, or built-up areas, allowing engineers to fit the road to the land, rather than forcing the land to fit the road. Compound curves help maintain a comfortable driving experience even in challenging terrain. Reverse curves, or S-curves, bend in opposite directions, often separated by a straight section for safety on high-speed roads. These curves are essential for changing the direction of a road without abrupt transitions, helping vehicles maintain stability and control. You'll often see S-curves where a highway needs to shift alignment to avoid obstacles or connect with another road. The spiral curve is the most sophisticated. Its radius changes gradually, easing you into or out of a turn. Spirals are especially important at highway interchanges and ramps, where vehicles transition from straight paths to sharp curves. By gradually tightening or loosening the curve, spirals reduce the risk of skidding and make high-speed turns safer and more comfortable. Spirals make highway interchanges feel smooth, letting drivers adjust naturally and allowing for gradual road banking, or super elevation. This banking tilts the road to counteract the forces of turning, keeping vehicles stable and reducing wear on tires. The result is a seamless driving experience, even at higher speeds. Each curve type is a tool, chosen to fit the landscape, speed, and safety needs. Engineers weigh factors like terrain, expected traffic volume, and the types of vehicles using the road. The right curve can mean the difference between a safe, efficient highway and a dangerous, uncomfortable one. Simple for straightforward transitions, compound for flexibility, reverse for alignment shifts, and spiral for comfort at speed. Each has its place, and the best roads use a mix to create routes that are both practical and pleasant to drive. These choices are the hidden artistry behind every safe, comfortable drive. The next time you're on a highway, notice how the curves guide you gently, almost effortlessly through the landscape. Next time you glide through a curve, know it's the result of careful engineering. Every detail, from the angle to the length, is designed with your safety and comfort in mind. The right curve type makes all the difference. It's a blend of science, creativity, and experience that shapes the roads we rely on every day. It's not just geometry, it's driver experience, safety, and flow. Well-designed curves keep traffic moving, reduce accidents, and make every journey more enjoyable. That's the real magic of road design, turning complex engineering into the simple pleasure of a smooth, safe drive. How do you turn a curve from a blueprint into reality? The answer lies in precision surveying, a blend of technical skill, mathematical calculation, and hands-on fieldwork that brings engineering drawings to life. The tangential angle method, also known as the deflection angle method, is a classic and time-tested way to lay out curves on the ground. It's a process that's been trusted by generations of surveyors and engineers to ensure accuracy and safety in road construction. The process begins at a critical location called the point of curvature, or PC. This is the exact spot where the straight section of road transitions into the curve, and it serves as the starting reference for all subsequent measurements. At the PC, the surveyor carefully sets up the instrument, aligning it precisely along the tangent or straight section of the road. Using calculated angles derived from the design plans, the surveyor is able to determine exactly where each point along the curve should be placed. For each station, often spaced at regular intervals such as every 100 feet, the surveyor turns the instrument by a specific deflection angle. This angle is calculated to ensure the curve follows the intended path. After turning the angle, the surveyor measures out the required distance and places a stake to mark the precise location. Each stake represents a carefully calculated point on the curve, acting as a physical guide for construction crews. These markers ensure that the road's alignment matches the engineer's design, down to the smallest detail. The process is systematic and repetitive. Turn the instrument, measure the distance, place the stake, and move forward to the next station. This rhythm continues until the entire curve is marked out. This methodical approach is what allows surveyors to translate complex geometric designs into real-world roads, ensuring that every curve is smooth, safe, and true to the original plan. It's a process that requires patience, attention to detail, and a deep understanding of both mathematics and the physical environment. Each stake hammered into the ground is a step toward a finished, functional roadway. The result? The seamless bends and graceful arcs you drive every day, often without a second thought, are the product of this careful, behind-the-scenes work. Surveying is where math meets mud, and where abstract plans are transformed into solid pavement. It's the crucial link between vision and reality. That's the backbone of every well-built curve, a testament to the precision, skill, and dedication of the surveyors and engineers who make it all possible. Choosing the right curve radius is critical for safety. Too tight, and it's dangerous. Too gentle, and it wastes space and money. Engineers calculate the minimum safe radius using physics, speed, tire friction, and road banking. Super elevation. Super elevation tilts the road, using gravity to help keep cars on track. The key formula: minimum radius, Shuckern speed 2, Shuckern 15x, super elevation plus friction. For example, a 60 mph curve with 6% super elevation and a friction factor of 0.12 needs a radius of about 1,033 feet. This ensures cars can safely navigate the curve at the intended speed. In practice, engineers often use a larger radius for extra safety. This calculation is the science behind every safe bend in the road. It's how engineers match road geometry to real-world driving. The right radius keeps traffic flowing and accidents down. It's a simple formula with life-saving impact. That's the power of engineering in action. Designing a curve is more than crunching numbers, it's a balancing act. The first step is setting the design speed, which determines everything from curve radius to sight distance. Sight distance is crucial. Drivers must see far enough ahead to react safely, even around bends. Obstacles like trees or hillsides can block views, so engineers may widen curves or clear obstructions. Terrain matters too. Flat land allows gentle curves. Mountains require tighter, more complex alignments. Engineers work with the landscape, minimizing environmental impact and construction costs. Horizontal and vertical alignments must work together. No sharp curves at the bottom of steep hills. Environmental constraints, like wetlands, also shape the design. Every curve is a puzzle. Safety, speed, terrain, cost, and environment must all fit. The best designs balance these competing demands. It's a blend of science, art, and practical problem solving. That's what makes a great road. A finished highway is more than asphalt. It's a symphony of engineering. Every curve is a blend of physics, geometry, and real-world constraints. Super elevation and friction work together to keep you safe. Spiral curves ease you into turns. Sight distance gives you time to react. Each element is a deliberate choice, woven into a safety net. The design accommodates everyone, from new drivers to truckers. Civil engineering's quiet success is making complex challenges invisible. The goal: connect people and places, safely and efficiently. Every curve is a link in that chain, a direct investment in public safety. That's the legacy of great road design. Designing a highway curve is a blend of math, science, and human focus. From the degree of curve to staking out the path, there's more to a bend than meets the eye. The 4 curve types are the building blocks of our road network. Spiral curves, in particular, show engineering's commitment to comfort and safety. Calculating the minimum radius ensures the road works with you, not against you. Every detail, from sightlines to alignment, is part of a holistic system. Highways are remarkable achievements built on trust and precision. Next time you take a curve, remember the thought and effort behind it. It's not just asphalt, it's a promise to get you home safely.